Welcome to Lesson 3 of Computer Game Production. If you haven't listened to Lessons 1 and 2, you need to go back and pick those up at u2.com. And take a look at the snowman here. We're moving from a 2D world in the previous lessons to a 3D world. The snowman appears to be three-dimensional, even though it's projected onto a flat surface. And if you look at it, it has a texture that appears on the surface. It has shadows, which is what helps to give it its 3D look. And in fact, the graphic system that you're using has not 2 dimensions, but 3 dimensions. The other thing you notice about the snowman is as soon as you look at it, you are drawn to what appears to be a face, even though on the surface of it, it is not much of a face at all, 2 little black spots and an orange nose, but humans are instinctively drawn to anything that looks like a face, and in fact in computer gaming a face is the most important aspect of any character that is drawn. The third dimension is referred to as the z-axis and is still in the Cartesian coordinate system. You can go back to Wikipedia and look at the additional material on the z-axis under Cartesian coordinates. And one of the things that you can experiment with, if you look at the draw.txt program, if you switch the lines around in it, just interchange them, you'll see that the resulting figure is different, and the reason is that the figures are drawn in Z order from back to front, so that if you interchange 2 lines, you may cause one figure to go to the front and one figure to go to the back. This ordering is important because if you have a say an attack element in a scene that is coming on as a threat, it has to be drawn so that it's not obscured in the Z order. In terms of coordinates, the z-axis positive is closer to your eye and the z-axis negative is moving away from your eye. So if you look at the Cartesian graph, in our system the x-axis goes left to right, the y-axis goes up and down, and the z-axis goes in and out, with the most positive z-coordinate being closest to your eye. If you increase the z-coordinate too much, it will go past your eye and you won't be able to see it. And if you decrease the z-coordinate too much, it will go to basically an infinity point in the distance. At this point, I'd like you to go to the bcook website for gaming and download the 7 new commands that are going to be used in this lesson. The .art command has been modified. You can still say .art space hyphen, but now you can say .art space and a program name. And after you've downloaded the commands into the M directory, I'd like you to type .art space perspective. If you look at the content of perspective.txt, you'll see that it uses a Z option on the line command to draw a line from a 3-dimensional point, x, y, and z, to another x, y, and z point, and in the picture that is drawn, the lines are all exactly the same width, but they're at different z positions. Notice that the further away the line is, the more it ends up vanishing or becoming smaller. This disappearing effect is called graphical perspective. Please review the material on the web at Wikipedia on graphical perspective. Notice that the further away an object is, the less details are needed to render it. This is very important in computer gaming because resources are everything. Using less resources for a distant object means that you can use more resources to make a near object more interesting to the viewer. If you have used racing games, for example, you may notice that the center of focus has a lot of detail, but the edges of the scene may be much less faithfully rendered. Next, I'd like you to read about color psychology, which is how color can be used to set the mood, either for a character or for a background. And the human eye, human psyche, has very definite ideas about which colors are uh, effective in certain situations and which ones aren't. The typical color system that is used in OpenGL and other graphics environment is called RGB. I'd like you to read about that as well. And we've also provided a link to a convenient color chart to help you easily select colors. Now start M and execute the command .art space snowman. Notice that draws a snowman using solid spheres and cones, and if you look at snowman.txt, it uses the commands .light, .material, .solid to end up drawing the snowman. Now I'd like you to follow the web links to read some introductory material about lighting a scene and lighting a solid surface. First, to light a surface, you have to have some light to reflect off of it, and that's where the .light command comes in. And then the surface itself can be described by ambient, diffuse, and specular light. Ambient light is light all around, like a light bulb has ambient light. It appears to come from within. Diffuse light is reflected off the surface of the object, and specular light is highlights that are a function of how shiny a particular object is. Once you've read the material, you might try .art space demo, the picture is included here, and try varying some of the parameters and some of the graphic files used to explore some of these different effects that you can get with various lighting options, surface options, and solid options, and try moving the light around to see what effect that has as well. See you in lesson 4.